I'm Doug Boreham from McMaster University in Canada, and my talk at this conference today was about adaptive responses and risk from yeast to the clinic. We're from McMaster University, and we have a lot of low-dose radiation research projects going there currently. I talked about yeast because yeast is where we first learned about how adaptive responses work. Small exposures to low-dose radiation can stimulate the yeast to become resistant to higher doses of radiation, and specifically resistant to other stresses. And we found out very early on that heat could induce resistance to radiation, and radiation could induce resistance to heat. And subsequently we learned that in a yeast cell, which is a eukaryotic cell like ours, you could actually expose the cells to low-dose radiation and also develop resistance to chemical carcinogens. Subsequent to that, we started looking at cells in culture, and ultimately led us to looking at how animals get cancer from being exposed to chemicals and high doses of radiation. And we learned again that low doses of radiation can actually protect animals from getting cancer and extend the latency period of cancer. So currently today we're working on experiments that are investigating the effects of low-dose radiation caused by medical exposures from the clinic, where you typically get exposed to diagnostic radiation or even low levels of therapeutic radiation. Our research is showing us that when you're exposed to something like a CT scan or a PET scan, it changes the way the cells in your body react to larger doses of radiation and can modulate or change the way your cancer risk works. Now currently, there are some people that believe that all the diagnostic radiation we're getting exposed to in the hospitals today could increase cancer risk in North America into the future. Our hypothesis is exactly opposite of that, and that is that diagnostic radiation may be inducing these adaptive responses that turn on protective mechanisms and reduce the risk of cancer. So over the next few years, we'll be doing animal studies to look at how PET scans and CT scans can change risk and change the way our bodies become cancer prone or cancer resistant.